any proof, we'll start with the top one. We rewrite it out. Draw the line. And one of the things that you're going to get better at as you do more proofs is after you draw the line, you're going to just take a moment to look at the equation and think about what are some different strategies I could use, right? You've always got, I can change the sine and cos strategy and get a single fraction, but then you're going to look at other things like we saw in that last example. Can I change everything to tangent? Or can I change everything to cotangent? And after looking at it for a few seconds, you're going to decide, maybe on this one, I'm going to change everything to sine and cos and see where it goes. So cotangent would be cos theta over sine theta. Plus tangent is sine theta over cos theta. Cosecant is 1 over sine theta. And secant is 1 over cos theta. While the right-hand side, I can multiply the tops and multiply the bottoms. It's really easy to get the right-hand side as a single fraction. The left-hand side. The left-hand side, I would add fractions. I need a common denominator. So this one's missing cos of theta. This one's missing sine of theta. Then I would have a common denominator of sine theta cos theta. And on the top, cos times cos would be cos squared. And sine would be sine squared. And now I'm really close. I've got a single fraction on both sides. One of the things that you're also going to get good at in your proofs is looking for hints. One side gives you a hint for the other side. For example, hey, my denominators are the same, but my numerators are different. This one has a 1. This one has a cos squared plus sine squared. And then maybe at that moment you're like, oh, I can always change sine squared theta plus cos squared theta to equal 1. That's one of my my Pythagorean identities. So I change it to 1. No work has to be shown for that. Therefore, the left side equals the right side. And we are all done. Okay. So this one, yes, question?
Do we have to show the work in blue, or can we just?
Yes, show that, right? Because what if I don't show this? I haven't got a common denominator, and then I've added fractions. So that's two things that you had to do mental math, so it's not showing enough work, right? Okay, but I didn't need to, like when adding the fractions, this together to cos squared, that's just one thing to do there. That's one thing to do there. It usually, if you're ever unsure, show the extra step of work. Because the amount of time that you actually spend thinking about should I show this work or not is about the same amount of time as it would take to show it. So just, I would say, just show the extra work. It's not that bad. Part B. If you use the strategy of changing the sine and cos, it will work. It will just take a lot longer. This is a good example of where taking a look at the question to begin with and think about different things that you could use could make it a lot shorter. In this one, I would look at the equation and I would notice I have a lot of cotangent and cosecant in the equation. That leads me to one of our new formulas, and I'll write it down up here. We know that cotangent squared theta plus 1 is equal to cosecant squared theta. And so all of the things that they're on your formula sheet, but you basically have to have them memorized. Because if they're not memorized, you won't think about looking at your formula sheet, and you won't think about the possibility of using them. So I looked at this proof, and I noticed cotangent and cosecant. That triggered in my mind that I had this identity that relates them, and at this moment I go, oh, if I change this cosecant squared theta to cotangent squared theta plus 1, then my proof only has cotangent. And maybe that will make it work a lot easier. Well, at this point, I could distribute this. That'll give me cotangent cubed theta plus cotangent theta minus cotangent theta. Well, these will be 0 because they're like terms, they'll go away. And I'm left with just cotangent cubed. And we are done. Pretty easy. What looked initially like it was going to be a long proof, especially if you change things to sine and cos, it would have been long, becomes shorter because we noticed something. So these new identities can make our life easier and quicker. Okay? I've added one more that we're going to do together. I'm going to take out this part. I'm going to draw our line. And the reason I added this one is sometimes the strategies you need to use are strategies you've learned in the past in algebra, in particular factoring. And one of the most common types of factoring that comes up in a proof is factoring a difference of squares. So reminder, what's the difference of squares? Something like x squared minus 9, which factors nicely to be x plus 3, x minus 3, is an example of a difference of squares. X squared is x times x, and 9 is 3 times 3. They're both squares, and there's a minus sign in between. So having that algebra skill and having the ability to factor can sometimes be a strategy. Again, in this one, I would be reluctant to change to sine and cos because my equation has tan and secant squared, and if I write it out from our formula sheet, I have that tan squared theta plus 1 is secant squared theta. So they're kind of telling me there's going to be a shorter way. If I change to sine and cos, it'll probably be a lot longer, and that on our formula sheet, that tan squared theta plus 1 is secant squared, there's a relationship between tan and secant, is telling me that I should probably not change things to sine and cos yet. See if there's other strategies. So, on the left-hand side, I have a difference of squares. Tan to the 4 minus secant to the 4. I can factor this to be tan squared times tan squared. That'll give me tan to the 4. Secant squared theta and secant squared theta. 1 will be plus, 1 will be minus. There's my difference of squares. Now, in one mental math manipulation, I'll do it in green. Can you see that you can get secant squared minus 1 is equal to tan squared? I can move the 1 over to the other side and get tan squared by itself and get secant squared theta minus 1. That would allow me to change any of my tan squared to secant squared minus 1. As far as figuring out which one I want to change, if I look in this first factor, and if I change the tan squared to secant squared theta minus 1, the secant squared theta will subtract the other secant squared theta and go away. That could be very advantageous. So as far as changing things go, I'm going to take this first tan squared, I'm going to change it to secant squared theta minus 1. I still have subtract secant squared theta. And I'm going to leave this one for now. These will subtract, and I'll be left with just a minus 1. That minus 1 has to get multiplied by this, so the minus 1 would get multiplied there and multiplied there. Would give me negative tan squared minus secant squared theta.
I know that you're in the middle of instruction, but I do need you for a very important thing.
Okay.